Hello again. In this video, I'm going to talk about an intramolecular aldol reaction or an Aldol cyclization. So when I say intramolecular, what I'm talking about is an aldol reaction in which the enolate and the electrophile are in the same molecule. And I'm going to give you an example, and I'm going to show you what types of rings will form and what types of rings will not form. Okay, but let's start with what can happen in an aldol cyclization. So you can see here I've got a compound that has a ketone, and that is a ketone and an aldehyde. Okay, and I've numbered my carbons, and I would recommend you do the same, especially the first couple of times you look at this, because it's easy to drop carbons or make connections at the wrong point. So if you remember, with base catalyzed conditions, sodium hydroxide and water, we can form an enolate. And I'm going to do it at carbon 6, okay? But we could, there's other places we could form an enolate, and I'll talk about that in a few minutes. But when we do that, and I'm going to kind of rearrange how this compound looks a little bit, just to make things easier, hopefully. 1, 2, 3, 4, 5, 6. Okay, so here's the enolate ion I form. I'm going to number my carbons again. All right, and here's a carbonyl carbon. If you remember, the second step of an aldol reaction is that we do a nucleophilic addition. Okay, so what's important to note here is we're forming a carbon-carbon bond in between carbon 6 and 1. All right, and so I'm going to do a couple steps here. I'm not giving you a full mechanism. We're going to do a nucleophilic addition followed by a proton transfer. And what that gets us to is this intermediate, which is okay, let me number this again. 1, 2, 3, 4, 5, 6, and our new bond is the 1,6 bond. And so you can see here's the alpha beta hydroxy ketone that we've made. Okay, and we might stop here. If we heated this, it would be an intermediate and would go on to form this alpha beta unsaturated ketone. Okay. So that's one option, and this kind of gives you a sense of what an aldol cyclization looks like. Okay, now you may have noticed that there's some other places that have alpha carbons. So not only is carbon 6 an alpha carbon, okay, but so is carbon 4 and carbon 2. And I want to show you what sort of product we might get if we form those enolates and why it's not the favorite cyclization. Okay, so let's maybe I'll go up here and let's say we enolize, and when I say enolize, I mean form an enolate at carbon 2. Okay, if we did that, actually I'll oops. Okay, so there's our carbon ion, 3, 4, 5, 6. Okay, let me put those numbers in here. 1, 2, 3, 4, 5, 6. Now when we cyclize, we're going to have carbon 2, or the lone pair on carbon 2 is going to attack carbon 5. And you can see here, if I count from carbon 2 to carbon 5, I'm going to get 1, 2, 3, 4 carbons in that ring. All right, so what this would look like, okay, after a couple steps. All right, is something like this, and I'm going to put some numbers on here. You kind of want to take this a little bit easy. Don't rush too fast. Okay. So we make the 2,5 bond. Okay. There we go. All right, so you can see here, if we form an enolate at carbon 2, when we cyclize, we're going to make a 4-membered ring. Now, it's going to be more favorable to make a 6-membered ring because there's less ring strain, okay? So if you find yourself, if you have a choice between cyclizing to make a 4 or 3-membered ring or to make a 5 or 6-membered ring, 5 or 6 is always going to be more favorable because there's less ring strain. Okay, so that's not going to be the major product. Okay, now we could also imagine, well, what if we enolize at C4? Okay. Oops. Okay, and so now let's see what that looks like. Negative charge there. Okay, let me put my numbers here. 1, 2, 3, 4, 5, 6. All right, so now when this cyclizes, we're going to have 4 attack carbon 1, and we're going to make a 4-1 bond. But again, I'm going to have 1, 2, 3, 4 carbons in that ring. So we'll make a 4-carbon ring. So again, that would be a product that's not favored. Okay, so even though we have 3 alpha carbons, only one of them is going to lead to a ring that doesn't have, or the 2 of the rings are 4-membered rings and one of them is 6-membered, and 6 is better than 4, which is why we form the 6-membered ring. Okay. Now, sometimes you may have instances where maybe you've got a choice between a 6-membered ring and something that's bigger, maybe like an 8-membered ring. In that case, again, we're going to favor the 6-membered ring, and I think that's because when you get to the 7 or 8 or 9-membered rings, then the there's more entropy involved, and so kind of the sweet spot is 5 or 6 carbons. All right, and so this is going to conclude this lecture on aldol cyclizations. Thanks for watching.